Hi, everyone.
Hi.
Hello.
Right, I was just waiting for Jaden to connect up and then we'll be there. Okay, so it's my pleasure to introduce to you today our speaker, Mr. Sven Wosny. Now, Sven studied electronics at the Helmut Schmidt University in Hamburg. He was also a technical officer in the German Air Force. But since 2000, he's been working in IT management, where he's variously been an IT consultant, divisional manager, and a managing director. From 2016 to 2020, which is where I met Sven, Sven was managing director of Schnelliker Digital Innovations, where he developed a digital strategy for the Schnelliker Group. And Schnelliker do the logistics for car companies such as Volkswagen. And he introduced new data-driven technology into the Schnelliker Group. Now, since 2020, he's been managing director of Wosny, and Wosny is a joint venture with Schnelliker to introduce AGVs, automated guided vehicles, and an AGV control system to warehouses. So I'll pass you over to Sven.
Yeah, hello everyone. Simon, thanks a lot for the introduction. I recognize myself, so it must have been me who are you talking about. Welcome all to my short speech about data and data in logistics. I wanna share my screen to support my speech a little bit, to give you a visual. Few visuals in parallel. So Simon talked about Wosny. Wosny is a company which is providing an AGV control system. I will introduce AGV technology, and I will introduce the potentials for logistics industry later on. But first, let me give you a few words about Wosny. We are a joint venture from Schnelliker, as Simon mentioned, and Göttingen KG. Göttingen KG is a German engineering and automation provider located in the near of Hanover. And for that, we are located in the near of Hanover as well. And we are burning for the AGV-based automation, since we think that there is a technology that will lead logistics to another level. I will focus that later on. The AGV control system is not integrated in the AGV itself, but it's just an orchestrator of AGVs, integrating AGVs into processes, into IT environments, and into infrastructures to make those AGVs most effective within the processes and keep out manual actions as far as possible. A short overview about my speech. I will give you a short glimpse about AGVs, and I will talk about logistics industry, what's going on and what will come up. I want to talk about processes within the logistics industry and the facts of AGV-based automation within these processes. And later on, I will come to data and algorithms and give you in parallel a short overview about our Wosny control, what is our software system. AGVs, maybe you've seen a lot of pictures. The most prominent use case for AGVs is, for instance, AWS and Amazon, supported by AWS. In their fulfillment centers, they are using AGVs to transport the shelves to the pickers, so that the pickers don't have to leave their picking place and just can pick out the goods from the shelf. As you see here, AGVs are in different sizes and in different types. Currently, we have at least 100 AGV producers within Europe. They're using different navigation and localization technologies. The former ones are using stripes or RFID tags on the floor. The modern ones are using natural navigation, laser navigation. They have different purposes. Undercut and underrun AGVs, as you can see down here where my mouse point is moving now, tuggers, forklifts, pallet movers, trucks, and there will be coming up more types of AGVs with special abilities. And all these AGVs needs to be integrated in the processes to provide their benefit, but there are some more aspects which are coming out with the integration of AGVs. Before we are focusing more on the AGVs, I will step over to the logistics and production logistics and the processes over there. The modern logistics we are operated since decades is mainly manually operated. There are IT support systems like WMS, warehouse management systems, where the handling units are located and the transport requirements are indicated and tracked, but only on discrete points, not over the road process. And there is no detailed knowledge about the processes running in the warehouse because of the lack of data. And due to that, there is no dynamic holistic control possible, means the processes are not really intelligent. Right now, we are going in a phase of a dynamic logistics. The process execution is sometimes done by AGVs or by robots. And in parallel, there are some of industrial Internet of Things applications, tracking applications, where the processes could be tracked in the warehouse and within the production area. But even if there are the data available now, most of them are unused. So the partly possible dynamic process control is not done very, very well. And the material flow is not really optimized right now. I will step in later on. But what I see for the future coming up in the next years, from my opinion, it is an intelligent logistic. And the intelligent logistic is focusing or is based on data. All these data won by the machines doing the process execution at the IoT applications, collecting additional data. All these data will be used and will be used in an intelligent way to do the logistic processes in a controllable and optimal way, just to make a big improvement in the logistics processes and in the production logistics processes. To give you a short impression about a logistics facility, I have one picture. You see there are a lot of racks of shops with aisles, a lot of people running around, forklifts going around, and it's not so easy to keep an overview over things going on there. And if we look on it, there's a Gesellschaft for industrielle Technik and Organisation, a German company for industrial technology and organization, and they had they did a future-oriented plant planning in 2018, and they said, Ziele der Layout Planning, I translated it for you in English, targets for layout design. They want to reduce the lead time, they want to optimize the material flow, they want a guarantee of flexibility, and they want a standardization of processes. Brilliant. But my question is, how can you optimize a material flow, and how can you guarantee flexibility if you have standardized processes? If you have standard processes or standardization of processes, that means you have defined storage areas where the goods are stored. There is no detailed consideration of the needs for the goods later on, or stock utilization or availability, turnover rate, and something like that. It's just roughly done. You have a defined material flow and you have a defined workflow. And within that, there is no consideration of shortages, damages, quality issues, whatever with the material, or within the workflow, the irregularities, faults, or particularities which can occur. If you define all that, that means you need personal buffer, material buffer, and time buffer. Because if you don't know what's going on in your process, and if you're not prepared for some issues, you need more personnel and you need a little bit more time to be sure that the process is coming to a good end. But that means money for personnel, money for the material buffer, and money for the time you need, what is not really sufficient right now, and which should be better in the future. And to do that better in the future, for my opinion, we need a dynamization in these processes. But for the dynamization in these processes, you need an intelligent material flow, an intelligent workflow, and an intelligent storage strategy. All that will guarantee those flexibilities, what you need in the future for intelligent logistics. And intelligence means you need to have a comprehensive transparency data, a real-time transparency. It's really important to get the data right now, not some days later. And you need an applicable transparency, means it's not only sufficient to have the data, you have to gather information from the data just to optimize the processes and to control the processes in the best way. All that means real-time data collection, data analysis, and intelligent data usage. As I mentioned, two transport providers are the AGV system and the IIoT devices, which are coming more and more in the logistics processes or the production logistics processes. If you're looking on those AGVs, autonomous guided vehicles, this picture is, for instance, from the Amazon Fulfillment Center, somewhere in the world, I don't know which. They are very smart. They are able to navigate on their own, and they can do the things what they're meant to do. But who is responsible for the process integration? Who is telling those AGVs the needs of the processes? You need to have a layer on top of the AGVs, which is orchestrating them in the needs for the needs of the processes. And that is done with an AGV control system. An AGV control system first is controlling AGVs, means what is how to go, which route do they have to take, and who is first on a crossroad and everything like that. There's a coordination, allocation of jobs to the AGVs. If you have same AGVs in the process, the question is what is the right one to do the job. If you have different AGVs, you have to look on the abilities of the AGVs on top. System integration, IT system integration, infrastructure integration. If you can imagine, if a manually operated forklift is going through a door, it's no problem for the operator to open the door with a button or with a I don't know the English word, sorry. But an AGV is not able to do that. So insofar you need the integration of the infrastructure in these processes. You need a process control and the process adaptation, because processes are moving over the time. They are not the same day by day. And all that means such an AGV control system brings benefits within the processes. And our Wosny control, it is an AGV control system which is bringing benefits. We are vendor independent. That is the broadcasting block now, sorry. We are vendor independent. We have a traffic management system, intelligent traffic management system. We are working with dynamic envelopes, means according to the speed and the size of the AGV, we are creating a virtual envelope around the AGV, so we are able to control the AGVs very clever, so that they don't disturb each other. We have an optimal route and job allocation algorithm, and that integration, individual process engines, and whatever you need to have a really good orchestration of an AGV fleet. Oops, wrong direction. Let me focus the intelligent traffic management and the optimal job allocation and routing. The effects are, in general, you have with the AGV-based automation, you have a staff reduction because you don't need any longer some operators for the tools. You have a quality improvement because those AGVs are working very consequent on the task they have to do. They are highly calculable. You know how long it'll take to proceed a job, and they are right efficient in doing what they do if they are controlled and orchestrated right well. But coming back to the processes and the benefits, real benefits of AGV-based automation within the logistic and production logistics, they are gathering more transparency, because an AGV is telling you all the time where it is and what it's doing. That means we have a lot of data within the process, with the ongoing process, and for that we have a complete control, and that leads to the possibility to do a lot of optimization within the process. So with the data we are gathering, we have a lot of potential for optimization of logistics. Let me have an example of what's going on right now, in the logistics. We have on the left hand a goods entry area. We have a lot of racks. So the goods are stored in the racks, and on the right hand we have a sequencing or kitting area. Focusing on the automotive industry, you need to set up some sequences or kits or car kits to deliver them to the production line, right according to the car which is produced. And so there is a kitting area. And sometimes we have a picking area in the lower level of the racks, where picking processes has to be done. The best way would be if a good from a good entry is going to a rack and directly is going to a kitting area or sequencing area, without disturbing the pickers in the lower levels and without unintelligent routings. But the reality is that we have not the shortest way. We are not taking it into account in which later area the material is produced, and a lot of more issues are not reflected in storing and transporting the goods. And even that is possible, forklift operators following his biology. And you have no control over that. You don't know what's going on. The question is, what is to do when and where? We have no sequencing scope, sorry. We have no sequencing scope, we have no picking scope, and we have no entry goods scope, but we need to have it to control that and to have a clever and intelligent material and workflow in that area. And the question is about how much time do we have to do all the things which is to be done? Which routes should be taken? How long will a transport take to be operated? And many questions around. And on top, what about troubleshooting if there are issues coming up which are not foreseeable? For instance, not enough parts in a handling unit, or damaged parts, or a forklift operator which drops a handling unit, whatever troubles coming up. day by day, and you have to handle them without breaking the processes and without stopping the production line by not supporting the goods. That is predominantly not possible and not done today because of the lack of data we have. At Schnellicke,
Sven, you're mute. That's it.
Yep, it's going on now. Sorry. At Schnellicke, my former company I was working for, we had two big approaches to bring more intelligence in those processes. First, we considered a dynamic store with the Fraunhofer Institute of Supply Chain Management in Nuremberg in Germany. We did a very, very good proof of concept. What we said, well, our aims were in that proof of concept to store all the goods in the rack area, in the storage area, with minimizing the costs for the handling costs and optimizing the usage of the storage area. So we looked at the dimension of goods and the fire load and the process requirements, and we looked on the storage area. We looked on the current inventory and the turnover of the relevant goods, and we looked on the handling times for the stackers to store the goods and to unstore the goods and bring them to the sequencing areas later on. And that is done with a machine learning approach. First, we did a pattern recognition at the sequencing area just to learn what's going on in these areas with the goods. And later on, we did a cost-based optimization for the handling times regarding all these aspects which are shown here, with the effect that we could reduce the handling times more than 20% in average. Currently, the algorithms are in the hands of the IT division of Schnellicke, and they try to integrate that in their systems. But believe me, it's not so easy to integrate that in an SAP system. But they're working on that because there are lots of effects, positive effects, which could be achieved with that. And a second idea we have sequencing areas, which has several sequencing areas which are very far from each other. So the workers have a long ways to go from one sequence area to another area. And so far, it was very useful to decide in which series he's processing the call-offs. Formerly, it was done by time. Yeah, it was a call-off coming in, so it had to be done. Nevertheless, if he's on the last end of the picking area and going to the other end to the area, it's just from the series he has of the call-off where he which has to be proceeded. We looked on the lead times for the call-off. It is necessary to do a call-off right after coming in the system. So we had, for some call-offs, we had a lot of time. For other call-offs, we have very short time and have to process that very quick. And to do the sequencing, because there are tools which has to be handled to do the sequencing, where the employees have to be experienced in. We looked on that. We looked on the workload balancing for the staff, and the main focus was to reduce the travel times and to optimize the whole process at all. And again, we did first the pattern recognition, looking what's coming up, how much time do we have, and what's going on over there, because the call-offs are not foreseeable for the time coming up. So we just did a pattern recognition to get an idea what's coming up within the next hours, and based on that, we did a cost optimization focused on the travel times of workers, and give the workers a clear focus what to do in an optimal way. And even that works, and we had a savings potential between 25 and 30% of working time. And so far, that is integrated right now in Schnellige processes. So that is the first idea what we can do with the data within intralogistics processes. And if you look further on in the future, there are more potentials to optimize material and workflow in the logistics area or the production logistics area. If you look at delivery patterns, on demand patterns, utilization patterns for storage areas, for fault patterns, that is very, very interesting to look what's coming up, what kind of fault is occurring on what time. Can you foresee some fault spreads? And the performance patterns of the players and the resources in the processes. If you consider all that and you bring those patterns in a certain dependence, then you can optimize the logistics in a very, very good way. I have to put the pictures away to be able to read my text. So you have a minimal material demand in the logistics area, in the shelves and the racks, because every material which has to be sorry, my English. Every material you need to be sure that the process is going on, even if a fault occurs, it costs money, and that is about money over there, and the resources on top are again costly. So we have to minimize them as well. And doing all the or identifying all the things going on with the pattern recognition and combining all these things and do a clever optimization algorithm on that based on this data will bring the logistics area to that area, or that phase, what I called intelligent logistics. And I think the savings in that area will be quite high, even if only 10 or 20% savings is possible. That are numbers for big players, many millions behind that. So my idea is that the future of logistics is a data-driven, intelligent logistics. And I think data science, the topic you're working on, will not only high and prominent or high relevant and prominent topic for the known industries like banking industries or insurance industries or whatever. It will be even important in the traditional industries like logistics and production and automation and everything like that. And so far, I can congratulate you to the choice of your studies, because, in my opinion, there is a big future for your abilities you're working on and trading on right now. So that's me. If you have any questions, you can see sven@maweisen.de will be my email address. Just come up to me and ask me. And if not, just ask Simon. We worked a couple of years together and we know each other quite well.